Hey, welcome back everyone to another video, and in this one I'm pretty excited to show off my new workstation system, and this is a part of a 3 yearly upgrade we get at work. And basically we can make whatever we want, but it like kind of needs to fit the purpose, which basically for me is building you know low level code. Maybe it's like a single Linux kernel or something like the Android OS or Yocto and stuff like that. So the target was to make something like Threadripper, but at a much lesser cost. So I ended up with a 3950X, Ryzen 9X, of course, and it's been an awesome experience. So I didn't get to really like professionally capture all of this because for the most part I was just too excited to get it over with and to have a working system. So I do have a fair bit of footage. So what I'll attempt to do is I will like do a commentary over it, and hopefully you guys can see what's happening, and I'll go through the parts and the choices I've made and stuff like that. So to begin with, we have the motherboard, which is the Asus TUF Gaming X570 plus Wi-Fi. Now, originally, I was planning to go with a workstation variant of the X570 motherboard that Asus provides. But the market right now is seriously volatile in terms of what's available and for how much. And the availability of the workstation motherboard was not really good. So again, Asus stuff provides a lot of the similar things, including like a 24/7 operation rating and stuff like that, really good quality caps, and other things of that matter that will help me push the CPU to its limit, but also push it to its limit for a much longer time, or like a longer duration at once. And the only thing that sort of I find missing between the two is like some of the workstation grade or like server grade connectors. The I don't know, U.F or U.2, yeah, U.2 SSDs, slots, and all that sort of stuff, which is fine because you can always add like a PCI Express card and get U.2, or even getting just like the U.2 SSD themselves is pretty difficult right now. So I wasn't too concerned about that. But at the end of the day, you get a pretty decent motherboard, and of course with the bonus of having some onboard graphics. As you can see, most of the VRMs are well heat sinked, and you have your standard four dual channel memory slots. The This is the PCIe 4 chipset, so X570, of course, which is that the reason you see a fan over the chipset heatsink. And now we get to the cooler. And the reason I'm getting to the cooler before getting to the CPU is that the motherboard backplate has to be changed. So I wanted to get that out of the way first before I install the CPU. The cooler is a Deepcool Assassin 3. It comes with like dual 120 mil fan. In performance itself, it is much better than Noctua D15, but by just a couple of degrees. And as for the silence side of things, it's as good in my experience. It's not. It runs at a very low RPM and still keeps the CPU under full load at around 70 degrees Celsius. And I've not cranked the fan curve at all, so it behaves really well, in my opinion. Comes with a bunch of accessories. Of course, they are aiming for both Intel and AMD platforms. So attaching this, you really have to sit down and read what each of those holes are on the back plate. So now I've just skipped to the back plate already installed, and I'm opening up the CPU. Now the reason is, for the backplate installation, I really needed to read and make sure I did everything correctly so that I don't mess anything up in terms of mounting pressure, which is very important. And again, we have the Ryzen 3950X, Ryzen 9. It's a 16 core, tops out at like 4 gigahertz, but has 3.5 gigahertz base, or like the max clock it can reach. and then it boosts anywhere from 3.5 to 4 gigahertz. Mine seems to be staying solid at 3.7, and I have not touched any overclocking or any of that sort of things. I've just kept everything at the minimum required power ratings. I like, I am more interested in the longevity of the chip rather than burst performance. Single core burst performance doesn't really matter. Like the IPC itself is much higher than my previous system, which was a mobile Xeon platform. That I don't really care if like a single thread boosts to 4 gigahertz. I'm more than happy in everything staying at 3.7 and working much better when all of the cores are under load. So I didn't really bother with anything else. Here's the memory kit. This is the Corsair Vengeance DDR4. It's rated for 300 megahertz. Again, that's sort of the only one I could find that was 32 gigs per memory stick, and I wanted a total of 128 gig because between VMs and AOSP builds that can run off pretty quickly. If you are surprised by that, let me tell you that a single AOSP build can consume, provided that you have enough memory, can consume upwards of 60 gigabytes, um, provided that you are running those that many threads and you have enough memory. So yeah, I mean, and then each VM can take 4 to 8 gigs, and if you're running multiple OSs, maybe between FreeBSD, Linux, and Windows VMs, it can easily take a lot of space. So I did struggle a bit with the memory installation because for as long I have built a PC, both the tabs opened up, and this is something new with LPDDR4 motherboards that I really wasn't aware about. That not both the tabs open up and just a single one does. So that kind of took me by surprise. So we can kind of skip that as well. All right, now we have all the memory sticks installed, and it's time to get some thermal grease on the CPU and attach the heatsink. So this is the Deep Cool Assassin 3. It's a huge heatsink. Like, I don't know if you guys can tell, but this thing is huge. It's about 120 millimeters square. Um, on one side, and then just as thick, and has like, I don't know, 8 or even 10 heat pipes per side, which is like seriously overkill. So this one's rated for like 280 watts, and I'm only pushing like 164 watts through it from what I've measured over using some of the some of the Ryzen utilities. Yeah, it's a huge beast. So one, two, three, four, five, six, seven. Yeah, it looks like 7 heat pipes per side, or maybe there's an eighth one hiding. But yeah, it's pretty dense, and cools really well. Again, didn't opt for the AIO because again, longevity. I don't really want something leaky in my system. This was going to be an all solid state build apart from the fans, and I like kept it that way. Right, so this is the part where I kind of messed up, and I hoped I had taken the old way out, which is not something major that happened, but it's just I decided to use like the credit card thingy they sent to spread the heat paste, um, and it just like it wasn't really a treat to work with. It kept hitting the tabs on the side, and it didn't have enough area to like spread it properly and for my hands to move properly, and it just became a thing I had to go through because I didn't want to like clean it all up and do it again. So cut to chase, I'm back installing the actual heatsink, and I know it's upside down. I'll correct it in a bit. And there it is. So I'm just going to screw it down, and that should be the end of it. And for those of you who are asking, yes, I did remove the plastic warning label from the heatsink, so we are pretty safe on that side. Uh, And yeah, so mounting mechanism was much simpler than I thought. The last time I changed the CPU heatsink was with the old i3 I have when I was making my NAS, and that was a pain to install and to manage, but this was much simpler. I think that was a deep cool as well, but that was a much smaller design and a much older design. So yeah, I just tighten it as much as I could. So you can see there is nice RAM clearance from the from the fins themselves. But that kind of very like minorly became an issue when installing the fans. But not too much to worry about. Um, However, I do have something to say about the fan installation mechanism itself. I have never worked with um, the hanger type like clips, the thin metal wire clips you use to attach the fan, and I was utterly confused the first time I tried it. Um, Not that there's not enough videos or documentation, it just is one of the pain points to insert them. And if like a vendor is providing the fans with the box, I would most more or less expect them to have them installed always, but that didn't seem to be the case. And it basically ended up taking more time than I had hoped for and was just annoying for the most part. Right, so that is the fan attached, and as you can see, there's very minimal clearance from the fan itself, and actually the fan on the memory side actually rides a bit higher. The reason I did the fans in this manner was to just, make sure the airflow was in one direction. I wanted it to go out the back of the case. And so otherwise I would have installed the fans, facing the other side. That would have also made the memory clearance not be an issue, although I might have hit the shielding over the front panel IO. So, I mean, either way, there was something blocking it. So yeah, huge heat sinks are a very tight fit, so make sure you get memories that aren't too long if you're planning a build like that. And just plug everything including the fan headers, and everything should be good to go at this point. And next up we move on to SSDs. Now, these are the ones, exactly the ones off of my old system. And the reason I have them, I am using them, is because the I had a lot of things already installed in it, work related and otherwise, and like installing a new operating system from scratch is a pain in the ass. And it also saved me quite a bunch on the budget, which kind of went through getting me the entire 128 gig of memory kit, which I'm kind of happy about. So yeah, the first one is a terabyte of M.2 SATA SSD. So not super fancy stuff, but that's like WD Blue. It's been serving me well so far, and I'm editing this video off of that, and scratch performance for video editing and build time performance is absolutely fine, and I've not seen anything go wrong. So yeah, just about like the size, 1 terabyte in like for my work kind of gets a bit low, because like the AOSP build sizes are big, the repository sizes are big, and if you add multiple Yocto trees from multiple vendors and BSPs and Xilinx toolkits and stuff like that, things add up, and one terabyte then suddenly becomes not so much. The second one is the more faster, aggressive one. This I bought about a year ago, and this is the WD Black 512 gig kit. This is where the main operating system and most of the tools reside, so it's like super quick to boot and everything. This is an actual NVMe PCI Gen 3 X4 drive. Comes with their fancy SN750 controller. Um, and it actually has a really fast read write speeds even in random. So random, I don't remember how much it was, but for the sequential stuff, I think it was around three and a half gigabyte a second. um, And yeah, and that sort of contributes to a lot of things. So yeah, that's my main OS drive, which also is a bit less but usable. I may have like maybe in like A90s or 80s gigabytes left, but that's about it. So this may mostly have big installs and development tools and compilers and all of that stuff. And by the time you end up with a compiler for multiple architectures, not just ARM 32 and ARM 64, and then you have large QEMU installs for mostly all the architectures, it just ends up taking up a lot of space. So that's like one of the things I have uh to take a look at as well, as and when the space runs out, I might have to upgrade at some point, but that should take a while. The other, yeah, so the difficulty I had with like installing one of these was that the pad beneath the heatsink, and trust me, it requires a heatsink. The pad beneath the heatsink uh, was sticky and was so thick that it was kind of impossible to align it before it actually stuck to the drive. So I had to pull it out over and over again to like properly make sure everything else was secured. All right, so the case was fairly heavy, so I did skip a lot of the part of opening up the case and installing the motherboard. But for those of you who are interested, this is the Corsair 570X, which is a all tempered glass panel case, which is super heavy. Now, this wasn't my first choice. I was going for the 750D, which is a nice all metal single, see-through panel case, big, much, about the same in size, but much lighter because there's no glass in it. Like this is like super heavy crap. Like I threw my back off by just carrying this machine back to my workspace. um yeah, it's a heavy case, but it's all RGB and all fancy. It's kind of difficult to get into, so you can't just like screw two thumb screws off, slide the slide panel off, and off you go. So like see how much reflective and cool that looks. But you know once it's installed and you put it back and you turn the system on, it actually really, really, really look good. So yeah, really nice and open case to work with, apart from the the glass side of things. So I'll try to like skip forward a bit because most of this is just like me trying stuff out. um, so let's get to the point where I install my GPU. Again, this is not a new purchase. GPU was an old one that I use in one of my older ARM systems. This is the RX 580. It's not super new, but it's also not super old. This good enough for what I want to do. I mean, this is not a system that I'd ever play a whole lot of games on. So, for compute stuff, this is pretty good, and AMD has a pretty good reputation when it comes to consumer grade GPUs that compute really well. And this is basically everything propped up. I don't think I have the power supply installed yet, so that should be the next part. But everything else considered, everything fit really well. I haven't cable matched yet. That comes on a bit later. All right, so where sort of the modular power supplies start, and I really, I guessed I really need that to make it all look neat and clean. So yeah, it's not actually as huge as I was expecting it to be. It was pretty small. The box looks huge because all of the wires are separate. Um, and yeah, and this is sort of what it looks on the other side of things. This is this shows the module connectors or the wire connectors at the back, which makes it a modular power supply. So you just connect for whatever expansion slot you need, or the CPU slots you need, and then from there on you leave the others unpopulated, so you don't have a mess of wires. I mean, you still have a mess of wires. It's really hard to get away without a mess of wires in these builds, unless you're doing like 100% custom cables, and that, like, custom cable build takes a long time because all the time you're just measuring out the cables and everything. So I have cabled up everything. I didn't record that part because one of the more work intensive parts where you can't always have a camera on your head and also work. So I have cable match and everything. This had a pretty neat backing to it, to put all the cable in, like kind of a backbone, and it fit there perfectly. So I have everything plugged in, and we will quickly go for a boot test. But apart from that, yeah, this is the system build. Our Ryzen 9 3950X, 128 gigs of memory at 300 megahertz, RX 580, and a 1.5 terabytes of SSD for storage. And yeah, let's go for a quick boot test. But before that, this is what the case looks fully assembled, all glass and all glass panels. So I'm just screwing back the last panel, and there's a bunch of kind of scarce IO on the top because most of it just LED controls, which I don't use. I mostly just keep it on white. It looks much cooler that way rather than always flashing stuff. Although, all right, time for the initial boot, and that powers on, and so that's how it looks. As I said, I keep it at white, and it looks really good that way. And the motherboard just lights up. And so for those of you who still don't believe me that Android builds actually take 62 gigs of memory, I mean, just wait and watch. This is like the part where it does. So from the last time I built Android, a lot of the inbuilt apps and services have gone to native ND, or the NDK, which is basically C++ is based SDK that they use. But the bits that are still Java just takes tons and tons of memory. As you can see, just hit 62 gigabytes. And once like the entire Java bit is done, it goes back to taking maybe 30 or 20 gigabytes at max. So that was it. Yeah, it performs really well. Just to give you some performance numbers, Linux kernel takes 3 minutes to build, and that's cross compiled for ARM64 and ARM64 dev config. That takes 3 minutes. Yocto, I didn't have a really nice Yocto benchmark yet, but the Balena OS takes about an hour, but that's also because it builds a package called Rustlang Native, and Rustlang Native is largely single-threaded operation. AOSP takes an hour to build, which is 4 hours less than my previous machine. And then what else? That is, Kodi takes like 6 minutes to build, including FFmpeg. Yeah, and that's sort of the build numbers I have. I don't know, Redux OS maybe takes 10-15 minutes to build. It's fast enough. So yeah, ample memory, ample CPU storage. This should be good for maybe the next 5 years or something like that. And again, this is the AM4 platform, so definitely very easily upgradable to whatever new Ryzen CPUs that come along. And if they are in fact faster than what I have right now, it should be a cheap and easy upgrade. And famous last words, but I don't think we are going to run out of 120 gigs anytime soon. So yeah, thank you so much for watching. I hope you enjoyed this video, and I will see you all in the next one.